recording the screen right now. And I was talking to a teacher, they said that she was at a meeting with, some of the top, where they have stuff for us as teachers to go to. And they said, are you guys required at your schools to, make videos and record your lessons? And they all laughed at her. No. So, it's just something we do here that they don't do at a lot of places. So use that tool, okay? Well, in college, it would have been awesome if I could have just gone and listened to a guy explain a problem again. It would have been huge. So use those tools. Okay, we're doing tests for parallelograms today. Really, this is the same thing as the previous section, just from a different perspective. In the section we did last time, 8.2, 8.2 said, this is a parallelogram, so, ... What did we find out to be true? What's the first thing?
Opposite sides are equal.
And I'm abbreviating. Opposite sides are what? Parallel? What else? 2. Opposite sides are what? Congruent. 3. Opposite angles. Opposite angles are what? Congruent. 4 up there on the list says consecutive. Angles are supplementary. 5. Six. Okay. Okay, that's what 8.2 said. What we're going to do is we're going to look at a picture and run some tests, say, is that a parallelogram? And every one of these will work as a test. What I mean by that is we're not going to say that's a parallelogram. You're going to look and see if you can find any of these to be true. If any one of them are true, then what? It's got to be a what? So you see what I'm saying? It's the same thing, just from a different perspective. I see some look like that they understand what I'm saying, some that look like, what in the world are you talking about? Okay? What we're saying here is, give me an example in real life of something from different perspectives. Well, we talked about if-then statements, right? So if I said, remember that, I think when, you guys might remember from the first year, when I did if-then statements, I always do this one. Maybe it's because it was always my job as a kid to take out the trash, I don't know. But I'd always do, if you take out the trash, then you can go to the movies, right? So what happened first? I took out the trash, right? As a result, what happened? I had to go to the movies. Well, here we're saying if this is a parallelogram, as a result, what? All of this happens. Well, what we're going to do today is flip that. Just like I'd say, if you saw me at the movies, then what did I probably do? I took out the trash, right? You see how that's from a different perspective? That's saying from the result, the other happened. Well, here what I'm going to do is say, hey, if you can find this to be true, then it must be a what? Parallelogram. If you can find this to be true, then it must be what? If you can find this to be true, then it must be what? All of these are tests for parallelograms. Okay? If you find any of these to be true, then you know you have a what? So if you looked up and you found that all the consecutive angles inside a quadrilateral added to 180, what do you think you could say? That quadrilateral must be a?
Parallel.
If I found that both sets of opposite sides were parallel, then I could say what? That thing's got to be a what? And then if I looked and I found that both sets of opposite sides were congruent, then I'd have to be able to say what? It's a? And you don't need to copy down my scribbles over here. There is a seventh test. If one set of opposite sides in a parallelogram are both parallel and congruent, then the quadrilateral must be a parallelogram. I did that in the long way, didn't I? So I've got this thing right here. What am I saying here? First thing, only what? One set. So I don't have to do, if I can find that this side is parallel to what? That side, but that same sides are both what? Congruent, then I can say this must be a parallelogram. So that's kind of our test that we're adding to it. All right. Everybody got this? Let's get those worksheets out and let's apply some of this concept. Okay. What they want us to do here on these are what? What does it say? Determine whether each quadrilateral is a parallelogram. If yes, write yes. If yes, give a reason for your answer. So not only do we have to say yes, we have to say why. Okay? Well, I don't have a whole lot of information, right? But if the opposite angles are congruent, what do I know about this? It has to be a what? Parallelogram. Do I know whether they're congruent? I know that this one is congruent to this one, but what do I have to make sure? If this one's 112, this one has to be what? How can I be for sure? How can I find that out? What do I know for sure about a four-sided figure? The angles add to what? So I could say, I could call this x, and I could say x plus 68 plus what? 68 plus 112, all of that has to equal what? What happens when I add all these up? Somebody tell me what that is. 248. If I subtract 248 from both sides, what do I get x to be? Huh? 112? Okay, so I have now proven that what? That has to be what? 112 as well. So this one is congruent to that one. So what's the answer here? Yes,
X equals.
because the opposite what? Angles are what? Congruent. Wasn't that number 3 on our list? Said that if it's a parallelogram, then opposite angles are congruent. So if I can prove that opposite angles are congruent, then it has to be a parallelogram. Does everybody understand? Logic there? Number 2. What do you guys think? Is that a parallelogram? But I have to say what? Why? And in your homework, I expect the same thing. Tell me why. So you would say because the, tell me what to write. Opposite sides are what? I think that's a great answer. Now, what about number 3? Is number 3 a parallelogram?
Yeah.
Tell me why.
Diagonal by, yeah.
What number is that? Number 5?
Yeah, that is number 3.
If you'll look, what does that mean? That means that this is congruent to that, so that means that's the midpoint of that side, and this is congruent to that, so that's the mid. So they do bisect each other, don't they? So yes, the what? Diagonals bisect each other. Oh, number 4 is a dandy. You're going to have to pull back on some knowledge, some things we've done before. Yep, I know. What's the answer, yes or no here?
Yes.
Why is the opposite side?
Question is, can you tell me why?
I don't know if opposite sides parallel.
What could we say? Because one set of
Angles.
opposite sides are what? Parallel and what? Congruent. Now, the question is, why can I say that? Does anybody know why? See, that's the thing. You can't say because they look like it.
Oh,
Well-
because the seventh test. On
Well,
part.
I've already said that this set is congruent to this one. They've given me that, haven't they? But what other information have they given me? That this is congruent to what? Why is that significant? Is this not two lines being cut by a transversal? And if the alternate interior angles are congruent, what do I know about these two lines? So that means because the alternate interior angles were congruent there, that means this has to be parallel to what? So that's how I got to this. You see what I mean by pulling some stuff from the past there? Because one set of opposite sides are parallel and what? You can't just decide that's the case. There has to be some logic that leads you to that. There is a theorem that says that if the alternate interior angles are congruent, then the two must be parallel. The two. All right, let's look at number 5. You got to remember, they're not asking if it looks like it. They're saying, do you have enough information here to for sure say that this is a parallelogram? Why is that? Okay, we have basically 7 tests. Do any of the tests say if one set is parallel and the other sets are congruent? For the parallel and congruent thing to work, it has to be like this one up here, doesn't it? It has to be the same side, both parallel and what? Congruent. See here, our tests say either both sets of opposite sides have to be congruent. I'll let you in a little secret. Here's another thing you could do. Could you draw this same situation in something that's obviously not a parallelogram? You guys probably see it all the time. I didn't do a great job of drawing it. I probably should have drawn that more like that. But if that was congruent to that, couldn't that be parallel to that? You know what that is? It is an isosceles trapezoid. An isosceles trapezoid, these two are congruent, and those two are what? And that's not a parallelogram, because obviously this side's not parallel to this side, is it? Eventually they're going to meet, aren't they? Okay, so that's why no. Here, is this a parallelogram? Tell me why. And both sets of opposite angles are congruent. They happen to be the same thing. They're all 90, right? But the opposite angles are congruent, are they not? This is a special type of parallelogram. It is called a rectangle. It looks, it looks like a square, but they didn't say that those are necessarily congruent, so all I can say is it's a rectangle. We'll talk about that later. Here, if this is congruent to this, what am I saying? That this has to be what? Parallel to this. This looks a lot like the one up here, doesn't it? Is this necessarily a parallelogram? Could be an isosceles trapezoid, couldn't it? Now, number 8. You know what sometimes can help you when you're doing these problems is figure out where they're trying to trick you. Why are they trying? What did they do here to? I mean, really, is there really any difference between this problem, number 2, which was obvious, right, and this one right here? What did they throw in there? They decided to draw a diagonal, didn't they? But does that really have anything to do with the fact that still the opposite sides are what? Congruent, right? So what's the answer here? Is this a parallelogram?
Yes.
Because why?
Because the opposite sides are congruent.
I do expect you guys to put in the time to write. I abbreviated some. I'm not saying you can't. I'm saying we can, you guys can take the time to draw this picture and then explain yourself, right?